In this lecture, we discuss about the Leibniz theorem to find out the nth derivative of product of two functions. Example number 1, find the nth derivative of y is equal to x square into e to the power ax. Now here, y is the product of two functions. One is the x square, another is the e to the power ax. So if we have to find the nth derivative of y is equal to x square into e to the power ax. Let us give it equation number 1. We know that by Leibniz theorem, what is Leibniz theorem? The nth derivative of product of two function is equal to un v plus n into n minus 1 v1 plus n into n minus 2 upon n minus 1 upon 2 un minus 2 v2 plus n into n minus 1 into n minus 2 upon 6 into un minus 3 v3 and so on. So if we want to find out the nth derivative of any product of two functions using the Leibniz theorem, we have to first write down 1, 2, 3 and 4 terms we have to write down of the Leibniz theorem. No need to write down the remaining terms. If we write down these 4 terms, then this is very much useful and it is sufficient to write all the terms. Now, the question is like that. Now here there are product of two functions. X square is the one function and e to the power x is the second function. Now since if we consider that it is the product of two functions, so question arises that which is u and which is v. This is very important question. Now how to identify that x square or e to the power x, out of these two functions, which one is u and which one is v? So identifying this thing is very simple. If the nth derivative of any function, this is the first function x square and e to the power x is the second function. If nth derivative of any two of the function is not equal to 0, then we consider that function as u. Here, if you find out what is the nth derivative of x square, right? Suppose n is greater than 2, then its value is 0. Clearly, x square is not the u function. The x square can be considered as v. So x square is nothing but function v. And now, if you find out the nth derivative of e to the power x, what is the nth derivative of e to the power x? It is nothing but a to the power n e to the power ax. Clearly, here the nth derivative of e to the power ax is not equal to 0. Therefore, this function will be u. So if we want to apply the Leibniz theorem to find out the nth derivative of product of two functions, we have to first identify which is u and which is v. And how to identify? We have to just take that what is the nth derivative of first function, since it is 0, so it should be v. And the nth derivative of e to the power x is not equal to 0, so this is u. Nth derivative, if the function's nth derivative is not equal to 0, we consider that is u, and the next function will be the v. Now, if the nth derivative of both functions are not equal to 0, then we are independent. We can choose any function as u, and then the next function will be another function will be v. Clearly, here u is equal to e to the power ax and v is equal to x square. Now, we have to first find what is the nth derivative of u. What is the nth derivative of u? Un is equal to a to the power n e to the power x. And now, what is the value of v? V is nothing but x square. Un is a to the power n e to the power x. V is equal to x square. Similarly, what is un minus 1? So we have to just put the value of n is n minus 1. If we replace n by n minus 1, we will get un minus 1. It is nothing but a to the power n minus 1 e to the power x. And similarly, if you want to find out the derivative of x square, v1, which is what? It is derivative of x square is 2x. Now, we want to find out the n minus 2. So replace n, this n by n minus 2. we get un minus 2. So just simply replace this n by n minus 2, a to the power n minus 2 e to the power x, and the derivative of 2x is nothing but 2. And if you find out n minus 3 derivative of un minus 3, a to the power n minus 3, we have to just replace this n by 3, e to the power x, and v3 will be 0 because this 2 is constant, so derivative of constant is 0. Now once we get the at least one function v3 or v4 or 0, then we stop to do the derivative. Let us substitute all these values in the equation number 2. Putting above values in equation number 2, we get, first thing, what is the value of nth derivative of uv, nth derivative of x square e to the power ax, which is equal to, what is un? First term is un into v, un into v. So un is nothing but a to the power n into e to the power ax, and v is equal to x square. Just look here, a to the power an e to the power ax and into x square. So this is x square and this is a to the power n e to the power x. First part is clear. Then second part, n, we have to first write down what is the value of n. N is n. Now what is un minus 1? Un minus 1 is nothing but a to the power n minus 1 e to the power x. Just look here, a to the power n, a to the power n minus 1 into e to the power x, and v1, this v1 is nothing but 2x. Similarly, if we substitute that this value is same, n into n minus 1 upon 2, we are not putting any value over here. And then next thing is un minus 2. Un minus 2 is nothing but a to the power n minus 2 e to the power x. Just look here. Into v2. This v2 is nothing but 2. Now, if you put the next part, what is the next part? N into n minus 1 into n minus 2 upon 6. Un minus 3 is nothing but a to the power n minus 3 e to the power x. But what is the value of v3? V3 is 0. So ultimately all the remaining term will become 0. So in this example, we have only the first term, second term, and third term. Fourth term onward, all will become 0. Now let us try to simplify it. Now e to the power ax, e to the power ax, and a to the power n minus 2. We want to take outside this term. A to the power n minus 2 e to the power ax. This 2 and 2 will cancel. So here, this is a to the power n. So a to the power n can be written as a to the power n can be written as a to the power n minus 2 a square. If we are taking a to the power n minus 2 outside, a to the power n minus 2 e to the power x outside, what is remaining in the first part? First x square is remaining, and a to the power n can be written as a to the power n minus 2. We have taken a to the power n minus 2 outside, so remaining is a square. So a square x square is remaining in the first part. Similarly here, this 2x into n means 2n ax, 2n x, or this is a to the power n minus 1. How to write down a to the power n minus 1, which can be written as a into a to the power n minus 2. And n minus 2, we have a to the power n minus 2, we have already taken outside. What is remaining over here? So a is remaining over here. So 2nax plus here, we have taken this outside, these two are cancelled. So what is remaining over here? A to the power, n into n minus 1. N into n minus 1, this is the remaining term. So this is what? This is the nth derivative of the given function y is equal to x square into e to the power ax. Thank you.